Occurrence of misprints. Assume that the typographical errors committed by a typesetter occur completely at random. Suppose that a book of 600 pages contains 600 such misprints. Use the Poisson distribution to calculate the probability that a page contains no misprints, a page contains at least 3 misprints. Okay, so first of all, I would like to concentrate on the completely random distribution of misprints. So a completely random, in other words, uniform distribution of 600 misprints on 600 pages would imply an average of 1 misprint per page. So I call n number of misprints in a page. With this argument about completely random or uniform distribution of misprints, I basically assume that n bar will be equal to 1. So I ask myself, what is the probability of having a misprint in one particular page? The probability P of having a misprint in a page would be 1 over 600, because I have a total of 600 misprints, so I have to choose 1 out of 600 to put it into this page. And so capital N, total number of misprints, is 600. So n bar is equal to capital N times P is 1 over 600 times 600, which is 1, as I assumed would be the case. So with this, I have capital N 600, a large number, P 1 over 600, P is much less than 1. With these two, I conclude that we can use Poisson distribution. So it is in the realm of Poisson distribution with these two numbers. So therefore, we can answer the question, what is the probability that a page contains no misprints? The Poisson distribution for n is lambda to the power n divided by n factorial e to the minus lambda, where lambda is n bar, which is capital N times P. So what is the probability of having n is equal to 0? It is lambda to 0 over 0 factorial e to the minus lambda, which is 1. So this is e to the minus lambda, and that is approximately equal to 0.37. So the answer to part A is 0.37 e to the minus 1. And let's consider part B now. In part B, we're asked to calculate the probability that a page contains at least 3 misprints. Okay, so if I consider the following cases, n is equal to 0, that a page contains no misprints, or n is equal to 1, that a page contains one misprint, or n is equal to 2, that a page contains two misprints, these would not fall into the category of having at least 3 misprints. So probability that n is greater or equal to 3, at least 3 misprints, is 1 minus the probability that n is equal to 0, or n is equal to 1, or n is equal to 2. So basically this would be 1 minus lambda to the n, so 1 to 0 over n factorial, 0 factorial, e to the minus lambda, e to minus 1, plus lambda to the n, 1 to the power 1 over 1 factorial e to the minus lambda, and plus lambda to the n, so 1 square over n factorial, 2 factorial e to the minus 1. So I find that probability that n is greater or equal to 3 would be 1 minus e to the minus 1 plus e to the minus 1 plus 1 over 2 e to the minus 1. So this would be 1 minus 5 over 2 e to the minus 1. And if you calculate this, this is approximately 0.08. So the probability that a page contains at least 3 misprints is rather low as expected. It is 0.08. Okay, so assume that typographical errors committed by a typesetter occur completely at random. So we said a completely random or uniform distribution of 600 such misprints on 600 pages would imply an average of 1 misprint per page. So we are assuming that in this distribution of misprints, the statistics would give us a mean value of 1 misprint per page. The probability P of having a misprint in a page is 1 over 600, because there are 600 misprints. We have to choose 1 out of 600. Total number of misprints is 600, and n bar is 1 over 600 times 600, which is 1. So as expected. So total number 600, probability 1 over 600, P is much less than 1, and capital N is large. This means we can use Poisson distribution. For n is equal to 0, the number of misprints is 0 for one page. We have 0.37, that is lambda to 0 over 0 factorial e to the minus lambda, where lambda is 1, which is n bar. So we find that lambda is 1. And the probability that a page has at least 3 misprints, that means it doesn't have, we have to discount the probability of having no misprints, 1 misprint and 2 misprints. That is probability that n is greater or equal to 3. So this gives us 1 minus 1 to 0 over 0 factorial e to minus 1, plus 1 to 1 over 1 factorial e to minus 1, plus 1 to 2 over 2 factorial e to minus 1. So we find that numerically the result is 0.08.